Welcome to this Unreal Engine Quick Start Guide. This video will give you an overview on how to set up interactive drivable vehicles by offering an introduction to the Chaos Vehicles plugin, as well as Unreal's Control Rig tool. Let's start by taking a look at the prerequisites for the use of Chaos Vehicles. The first thing you'll need is for your vehicle to be a skeletal mesh with a root parent bone and a wheel bone for each wheel in your vehicle, in this case 4. The second thing to keep in mind is the vehicle orientation. The front should be facing the x-axis and the top the z-axis. That means the wheels will spin in the y-axis and steer in the z-axis. Before we can start working with Chaos Vehicles, we first need to enable the plugin, since it's disabled by default. Open the Plugin Manager window in the Edit menu. Type Chaos Vehicle in the search bar. Look for the Chaos Vehicles plugin and enable it. For the Chaos Vehicles plugin to load, you'll have to restart Unreal Engine. Go to the Edit menu and click on Project Settings to open the Project Settings window. On the left side panel, look for the Input Settings and click on it. Go to Axis Mappings and add a new one. Call it Forward Reverse. Click on the Select Key Value button and press W. Click on the plus button to add another entry and bind it to the S key. On the Scale field next to this entry, type -1. Create another mapping and call it Left-Right. Create 2 entries and map them to the A and D keys. Set the scale of A to -1. Let's create one last mapping. This time, we'll create an action mapping named Brake. Bind it to the spacebar. This should be enough for now. We can always come back later and change these bindings if necessary, add new ones, etc. At this point, we are ready to start setting up the vehicle. We'll start with the physics asset. When importing a skeletal mesh, Unreal creates physics bodies by default. Delete them all. In the skeleton tree panel, click on the button on the upper right and select Show Mesh Bones. First, we'll set up the root of the vehicle. Select the bone corresponding to the root of the vehicle. In the Tools panel, change the primitive type to Box. Then uncheck Auto Orient to Bone. Now click on Add Bodies. You can scale the box to adjust it to the volume of the mesh. Next, we'll set up the wheels. Select all 4 bones corresponding to the wheels. Change the primitive type to Sphere. This time, you'll want to check the Auto Orient to Bone checkbox. Finally, click on Add Bodies. Select the newly generated wheel bodies and go to the Details panel. There, on the Physics Type dropdown, choose Kinematic. And select Disabled in the Collision Response drop-down menu. That concludes the setup for the physics asset. Remember to save your work. The next step will be setting up the blueprints for the wheels. Let's create a blueprint of the Chaos Vehicle wheel class. We will use this blueprint to set up the front wheels. Select Front on the Axle Type drop-down menu. Now, we need to add the values for wheel radius and wheel width. We can find out those values in Unreal Engine quite easily. Drag and drop the skeletal mesh onto the editor. Switch to the top view by pressing Alt-J and zoom in to one of the wheels. Drag the middle mouse button to enable the Measure tool. Write down the width and diameter values. Back to our blueprint, fill in the wheel radius and wheel width fields with the values you just measured. Remember that the value for the radius should be half the diameter. Next, set the friction force multiplier to 4. Enable the Affected by Steering checkbox and set the max steer angle value. This value is measured in degrees. Compile and save the blueprint. Let's duplicate this blueprint to create the back wheels by pressing Ctrl D. This time, we'll set the axle type to rear. Enable the Affected by Engine checkbox and disable Affected by Steering. We're finished. Compile and save. The next thing we need for our vehicle is an animation blueprint. In the content browser, select the skeleton and right-click on it. Go to Create and select Anim Blueprint. Open it. Locate the parent class setting on the Details panel and set it to Vehicle Animation Instance. Right-click on the graph and select Mesh Space Ref Pose. Add one more node, Wheel Controller for Wheeled Vehicle. Next, connect Mesh Space Ref Pose to the Wheel Controller, and this to the Output Pose. That's it. Compile and save. We will now set up the blueprint for the vehicle proper. Start by right-clicking on the content browser and creating a new blueprint of the Wheeled Vehicle Bone class. Select the mesh component and assign it the skeletal mesh. Under the Animation section in the Details panel, assign the previously created animation blueprint to Anim class. Enable the Simulate Physics checkbox. Now select the Vehicle Movement component. Go to the Details panel and under the Wheel Setup section, click 4 times on the Add Element button to add 4 entries, 1 per each wheel. Assign the front wheel blueprint we created earlier to the wheel class slot of the first 2 entries, and the rear wheel blueprint to the last couple. In the bone name field of each of these entries, enter the name of the corresponding wheel bones. Remember that for the rig to work properly, the 2 bones corresponding to the front wheels should be assigned to the entries using the front wheel class, and the bones corresponding to the rear wheels to the entries with the rear wheel class. Next, go down to the Mechanical Setup section and under Engine Setup, click on Create External Curve. Choose a name as well as a folder to save the curve asset in. Double-click on the curved slot to edit it. With the middle mouse button, you can create points on the curve. Let's create 4 of them. Give each point the following values respectively: 0, 0.5. 1,000, 1.0. 4,000, 0.8. 5,000, 0.5. Click the Zoom to Fit button to frame the curve and see how it looks. Save it. Finally, set max RPM to 5,000. Now, we will proceed to set up the basic controls to operate the vehicle. Let's go to the event graph and start from a blank slate. Right-click and add an input axis forward-reverse node. This input is referencing the axis mappings we set up earlier. Add another input axis node for left-right. And yet another one for brake action. Drag and drop the vehicle movement component to the graph. Drag its output and type set throttle input. Drag the output once more and this time select set steering input. Drag it one last time and pick the set brake input node. Connect the axis value output pin of input axis forward reverse to the throttle pin of set throttle input. Likewise, connect the axis value of input axis left right to the steering input of set steering input. Finally, connect input action brake to set brake input. Compile and save. Before putting our vehicle to the test, let's set up a camera real quick. In the Components panel, select Mesh and click on the Add button. Add a spring arm component. Now select the spring arm and add a camera component. Select the spring arm once again and in the Details panel, check the Enable Camera Rotation Lag checkbox. Next, set the camera rotation lag speed to 2. Finally, position the spring arm anywhere you want. You're done. Compile and save your blueprint. Drag and drop the blueprint to the editor. In the Details panel, go to the Auto-Possess plier and select Plier 0. Press Alt-P. As you can see, currently the vehicle is very unstable and hard to control. Let's lower the center of mass to fix it. Select the Vehicle Movement component in the vehicle blueprint. Enable the Center of Mass override and adjust the value on the Z-axis. Compile and save. Press Alt-P once more. As you can see, the vehicle is more responsive now. This should be enough to get you started. There are many more adjustments you can make to fine-tune your vehicle. Check out the documentation for more details on all the various settings available to you to bring your vehicles to the next level. Now that our vehicle is drivable thanks to Chaos Vehicles, it's time to take a look at the suspension. As you can see, the body and wheels of the vehicle are responding to the irregularities of the terrain as expected. However, the suspension is completely rigid and not working at all. We will fix this by using Control Rig. But before we do that, let's take a closer look at the elements that make up the suspension. The lower control arm, the upper arm, the shock absorber or damper, the drive shaft or tie rod, and in the front axle, the steering link and the knuckle. Let's also take a quick look at the concept of forward and inverse kinematics and see how it applies to the task at hand. In a forward kinematic system, or FK, the components of a skeleton, known as bones or joints, are moved by applying rotation to the bones in the hierarchy individually. In an inverse kinematic system, or IK, a target or effector is added to the end of the chain. Instead of directly rotating the bones, just the position of the target needs to be changed, and the IK solver will calculate the rotation of each joint to try and follow said target. Using an IK system, we can keep the parent of the chain locked to the root of the vehicle, while the target is constrained to the wheels. Thus, the IK solver can take care of dynamically calculating the rotation of the suspension elements in between. Let's set up the suspension, shall we? Control Rig is Unreal Engine's rigging and animation system. It's meant to allow Unreal users to animate characters directly within the engine without requiring the use of an external app such as Maya or Blender. It supports both FK and IK, a feature that we will take advantage of to rig the suspension of our vehicle. Right-click on the skeletal mesh. Select Control Rig under the Create menu. Open the control rig by double-clicking on it. We will start by setting up the front suspension right-hand side. In the rig hierarchy panel, locate the bone knuckle FR as in front right and drag and drop it to the graph. Select Get Bone from the menu. Repeat these steps for the bones Upper Arm Start 01 FR, Damper Start FR, Damper End FR, Steering Link Start FR, and Steering Link End FR. Right-click and type Parent Constraint. Set Knuckle FR as child. Expand the filter settings and there expand both the translation and rotation filters. Disable then the X and the Y checkboxes in both. Next, go to the Parent section and locate Name under Item. Assign the wheel FR. In Advanced Settings, change the rotation order for filter from the default XCY to XYZ. Right-click again and this time let's pick Basic IK. Set Pole Vector Kind to Location. Assign Knuckle FR to Pole Vector Space. Now, create 6 duplicates of this node by pressing Ctrl D until you have 7 in total. Lay your nodes so that you can work in an organized manner. Connect the output of the Knuckle FR Get Transform node to the effector inputs of the first and third basic IK nodes. To this same node, assign Lower Arm 01 FR as item A, lower arm 02 FR as item B and knuckle FR as effector item. Connect the output of upper arm start 01 FR get transform node to the effector pin of the second basic IK. Here, assign upper arm 01 FR as item A, upper arm 02 FR as item B, and upper arm start 01 FR as effector item. In the third basic IK node, assign tie rod 01 FR as item A, tie rod 02 FR as item B, and knuckle FR as effector item. Drag the output of the damper start FR get transform node to the effector input of the fourth basic IK. Assign damper B01 FR as item A, damper B02 FR as item B, and damper start FR as effector item. Now grab the output of damper end FR and plug it into the effector pin of the fifth basic IK node. Again, let's start populating the various item slots. Damper A01 FR in item A, damper A02 FR in item B, and damper end FR in effector item. Connect the output of the steering link start FR get transform to the effector input of the sixth basic IK. In this node, assign steering link V01 FR as item A, steering link V02 FR as item B, and steering link start FR as effector item. Next, connect the get transform output of steering link end FR to the last basic IK. Assign steering link A01 FR as item A, steering link A02 FR as item B, and steering link end FR as the effector item. Connect the execution output of the forwards solve node to the execution input of the parent constraint, and this to the first basic IK, and so on. The rear suspension is a little bit simpler than the front one. Select the parent constraint node, 5 of the body IK nodes, and 4 of the get transform nodes. Press Ctrl D to duplicate them. Assign the bones knuckle RR, upper arm start 01 RR, damper start RR, and damper end RR to each one of the 4 get transform nodes. In this case, RR stands for rear right. Select Parent Constraint and set Knuckle RR as child and Wheel RR as parent. Select the first basic IK and assign lower arm 01 RR as item A, lower arm 02 RR as item B, and knuckle RR as effector item. On to the second basic IK node. Assign upper arm 01 RR as item A, upper arm 02 RR as item B, and upper arm start 01 RR as effector item. Now, select the third basic IK and assign tie road 01 RR as item A, tie road 02 RR as item B, and knuckle RR as effector item. In the fourth basic IK, assign damper V01 RR as item A, damper V02 RR as item B, and damper start RR as effector item. Select the last basic IK node and assign damper A01 RR as item A, damper A02 RR as item B, and damper end RR as effector item. This concludes the setup for the front and rear suspension on the right side. Now all we have to do is duplicate the nodes and reassign the corresponding bones on the left side. Let's group the nodes using comments to make the graph more readable. Keep in mind that this setup is specific to this vehicle. Different vehicles might require a drastically different one. Also, not every vehicle needs such a complex suspension system. In most cases, you might not even need one at all, since in many vehicles it's not even visible. As a final step, and just for the sake of keeping things organized, let's add a sequence node and connect its input to the forward solve. Next, connect the A output to the parent constraint of the front right suspension. Now, connect the B output to the parent constraint of the front left suspension. Click on Add Pin. Connect the C output to the rear right suspension and D to the rear left. One last thing I forgot earlier. Make sure the secondary axis weight of the basic IK nodes is set to 0. Compile and save. In order for the suspension to work, we need to update the animation blueprint. Make some space and add a control rig node between component to local and output pose. Select control rig and in the details panel, assign our control rig asset as the control rig class. Compile and save. With the use of control rig and IKs, or inverse kinematics, the suspension now follows the motion of the wheels, the springs compress, etc. As a bonus, I'll show you how to add a toggle to enable and disable the windshield wipers. First, we need to add another input key to the project. We are going to create a new action mapping. We'll call it wipers and bind it to the Q key. Let's edit our control rig to add the wipers. In the hierarchy panel, look for the bones corresponding to the wipers. Right-click on Wiper L and select New Control. Select the newly created control and in the Details panel, pick Half Circle Thin from the Shape drop-down menu. Set the scale to 2. Rotate it 180 degrees in the Z-axis. And move it 10 units also in the Z-axis. Create another control for the wiper R bone. Once again, change its shape to half circle thin. And set the transforms with the same values as before. Drag and drop both controls to the graph. Select Get Control in the pop-up menu. Now, drag and drop the bones and select Set Bone. connect the output of the wiper L getTransform node to the corresponding setTransform node. Do the same with the wiper R and don't forget to connect the execute pin as well. Add a new pin to the sequence node and connect it to the one of the wiper nodes. Create a comment to group these nodes together. Compile and save your work. Now, we need to update the animation blueprint. Select the Control Rig node. In the Details panel, look for the Input section. Enable both wiper control checkboxes. 2 new input pins should show up in the node. Right-click in one of those pins and select Split Struct Pin. Do the same with the other one. Now, right-click on the rotation transform and again select Split Struct Pin. Do it for both wiper L and wiper R. Next, go to my Blueprint panel and click the plus button on the Variables section. Change the type to float. Create another variable of the same type. Drag and drop these variables to the graph. Connect each variable to the corresponding rotation C or yaw input. Compile and save. Finally, we'll update the vehicle blueprint to add the new functionality. Let's start by creating a variable of the type Boolean. Right-click on the graph and type branch to add a branch node. Drag and drop the variable. Connect it to the condition input of the branch node. Drag and drop the variable again, but this time select Set. Press Ctrl D to duplicate it. Enable the checkbox in one of them and leave it disabled in the other one. Let's add another node, a timeline. A new variable with the same name as your timeline should appear in the list of variables in the left side. Double-click on the timeline. Press the Add Track button and select Float Track. Right-click on the curve and select Add Key. Add 2 more keys. Set time and value for the first key to 0. Set the time of the last key to 1 and leave value at 0. Set the time of the second key to 0.35 and value to -90. right-click on the keys and select Auto. Drag and drop the timeline variable to the graph. Drag its output pin and type Set Looping. Duplicate it and enable the New Looping checkbox. Drag a connection from the false output of the branch node to the Boolean variable with the checkbox enabled. Drag another one from the true output to the other Boolean, and from there to the Set Looping node. Do the same with the other variable. Connect the Set Looping node with the enabled checkbox to the Play from Start input of the timeline. Now, drag and drop the mesh component. Drag its output and select Get Anim Instance. Next, drag the return value output pin and type Cast to. Add a Cast to Animation Blueprint node. Right-click on it and select Convert to Pure Cast. Drag the blue output pin and type Set, followed by one of the variables we created earlier in the animation blueprint. Do the same with the other variable. Connect the new track output of the timeline to the input of the left wiper set node. Connect the update output of the timeline to one of the set nodes, and this to the other set node. Drag the new track output of the timeline and add a multiply node. Type -1. Connect the multiply output to the remaining set node. Add an input action wipers node. Connect its pressed output to the branch node. Lastly, double-click on the timeline and set its length to 1. Done. Compile and save. There you go. Now you have a nice set of working windshield wipers that can be toggled on and off at will. If you've made it this far, you should now have a fully functional vehicle that you can drive around. In this video, we just covered the basics of Chaos vehicles and its power in combination with Control Rig, but there is so much more you can achieve. There's plenty of videos here in YouTube where you can learn more. On top of that, you can go to unrealengine.com or join my Discord server to go even further with your vehicle rigs. No pun intended. Thanks for watching, and I will see you soon.